So thank you so much for the invitation and having me here. I'll try to speak in English. If you have any issues in hearing or understanding me, please raise your hand. I'll try to explain my view or Shift Lab's view on DevSecOps, and I hope that it will become clear for everyone that is not a boogeyman. So either you call it rugged, DevOps, I need to read it because all these combinations of names is DevOps, Sec DevOps, whatever you want to call it. We prefer to call it good sense. So, and just to start with some concepts or basic concepts, so we understand what where we're coming from and what we try to explain regarding DevSecOps. I will try to present at least some ideas of what three main aspects of today's delivery process are all about. First, I would like to talk about Agile and explain a little bit what is Agile in our perspective. Agile, and let's start by talking about the Agile Manifesto from the year 2000 and a few. Agile Manifesto didn't appear in the first time I read it and I signed it. It was about improving the software process. It was about bringing users to the process, involving users, using tools to speed up the development. Agile was all about that. Today, Agile is outside of the development lifecycle. Agile is about pretty much everything. You start to have Kanban, Scrum, all of those tools being applied to other areas of the organization. So this it's a good thing. So what initially started as a measure to improve the software development process has now scaled from that. So, but Agile, the focus or the primary focus of Agile, this hasn't changed, is the process. That's where it targets. It targets on the process, and it tries to change the process to bring to generate more acceleration to that process. So those are the key aspects of Agile. And then we have another buzzword for today, which is continuous integration, continuous deployment, continuous delivery, continuous. And this is still within the software development lifecycle. That's the target. That's still a target. It hasn't changed from this. But it's a good thing that this appears on its own on today's concerns, because, again, 12 years ago when I signed the manifesto, continuous integration was a tool of Agile, was a way to do Agile, along with extreme programming, test-driven development, and eventually we're going to see those tools emerging from that Agile process as they become more emergent. But CI/CD, the focus of CI, again, is software lifecycle, is to focus on software, and the idea is to apply tools to bring automation to the process. Okay, and then the buzzword for today is DevOps. The focus of DevOps is to change the culture of the organization. It uses people and leverages people's skills and capabilities to enable or to promote collaboration, so a better result of the entire development process emerges. Okay, so these three concepts are relevant, at least for us to understand. They are not. There's no evolution in here. We cannot say that first there was Agile, then there was continuous integration. Then, in theory, you can have DevOps without any automation. In theory, okay. I'm not sure if it works very well, but you can have it, okay. And you can have Agile without continuous integration. You can, okay. In theory, you can. But those three aspects of those three activities, they work together all together to improve the software life cycle. Speed and quality and security. So when we have DevOps, we have a very well-oiled machine. So we have good requirements, producing good software in an automated way. That's what we want, with some human intervention. The moving to operations is a smooth thing. It's a smooth aspect. Operations are part of the development process, so they understand how the software works. They understand what needs to be changed, and it's a smooth process. But we only are talking about DevOps, and then we have security, and this is the
Before we go on, are you speaking about continuous deploy or continuous delivery?
Both.
So that's continuous deploy.
You call continuous star, okay. And then we have security. And this is just a subset of what the topics on security are all about. So we have a complex world about security. And it's difficult, if you can understand that, it's a bit difficult for everyone to know a little bit about everything. So it's difficult to bring that into the development life cycle. Okay? But if you don't, we leave security lagging. Or either that, or the buzz stops, so in order for security to catch up. So we need to do something about it. Obviously, that we have the first option is not do anything, and the compromise on security, and just do a little bit, and what we understand is that that doesn't work. And if you do think that it works, and I was trying to find some examples in here to have some major examples of security issues in 2018, but there were so many. I decided that I'd rather present the list and a couple of sites, to present a couple of lists of issues that were reported in March 2018. That one is 63 events, serious events on cybersecurity events up to 15th of March. 63 reported. Again, there is not a consolidated list for this, so there are multiple sources. So if you want to look into that Armageddon, it's a good site, and it has a daily list, and of the timeline for events. And we can, while this one is more American or United States events, and that one it tries to be a bit global, and you can see that you have Italy situation occur in 8th of March, and you have a situation in Saudi Arabia and United States and UK. So that's interesting. So just to let you know that if you compromise security, our name will appear in there. As simple as that, sooner or later. Okay, but so we don't believe that this only happens to others. Those are situations that occur in Portugal. Again, not exhaustive. We have a problem in Portugal that either because people fail to identify or they pretend or fail to report, but the number of events in Portugal doesn't match with the average of events in the rest of the world. Maybe we are very good, or maybe we're not very good in detecting our events. But those are three issues that are more or less known to everyone. So, but just let know that this doesn't only happen to others. This can happen to us as well. Okay, and we can always have the second option, which is okay. Let's do DevOps as we know it, and leave the security part for later. And that doesn't work also. So what we try to do with DevOps, basically, is to apply agile techniques, to do automation in order to bring value to the organization faster, of high value, and we manage the source properly. We use continuous integration servers. We automate testing. We do all we can to produce faster results to the organization. And basically what we try to do with DevSecOps is just to bring security in that process. We're not creating a new process, not bringing anything new, just adding a few tools and techniques into the DevOps process so we can have security, so we can produce value with efficiency, but also with confidence and trust in the applications we are producing. Okay? Wow. Mind-blowing. We all know this, right? This is a DevOps life cycle, or DevOps cycle, if you want to call it, or tool chain, if you want to call it. And for DevSecOps, we had a few set of instructions, things that we can do along those lines. So we can do pen testing prior to go to production. We can do static analysis during development. We can configure RASP already in production, and so on. So those are a series of activities related to security that you should be able to implement during our DevOps cycle. Now, not everyone knows about everything, so that's why this is a cultural change. You need to bring the organization together, not only the users to help us to define the requirements and to test the applications early in the life cycle, but also the operations to help us understand how they can be deployed, but also security members in order to understand how can you do, I don't know, attack surface analysis. That's something that we need to do. And might as well do it early in the life cycle than in production. Or to help us identify if I have open source component in my design that is not safe. That should be done early in the life cycle. It will be very sad if you spend some time or prepare a design for a solution based on an open source component to later find that that component is not safe and I need to change my redesign again. So all DevOps principles will be gone. Introducing a new concept is not secure socket layers, by the way, SSL, in this case, talking about shift security left. That's what we want to do. We want to implement in our development lifecycle a concept of secure software development lifecycle. And again, this is no rocket science. It's just a set of instructions, a set of procedures, a set of events that we need to develop throughout the development process. And I know that this is a flat line, and people looking at that flat line looks at, oh, but this is only for waterfall because we have no cycles in there. Just imagine that those cycles have been ironed out. The activities are the same. Okay, they always happen. They can happen in 6 months' time, or can happen in 3 weeks' time, or 1 week time. But same events happen. When we are doing requirements elicitation, it will be good to have something or some checklist or some predefined requirements that help us out identify what are the security requirements for my application. So we can do that. If I'm designing, I would like to have some reusable components that I know that will help me out in implementation. I can have an audit log model, for instance, that allow me to record all my audit logs for my application, or input validation model that allows me. So those are the reusable components, and so on. So what we try to do, again, is moving from that typical modeling of penetration testing in production, or first testing sometimes in production, and patch up my security in production through bring the problems early to the life cycle. Agile, DevSecOps, continuous integration, that's the same things, okay? So far, blah, 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 we talked about DevSecOps. Now let's try to look into some more concrete aspects of this. First, questions. We still need to look into our organization and start doing some questions regarding people. Is my team aware or is my team, does my team knows about secure software? They are aware of the practices. Are they trained? Are they maintaining the good code? Are they testing the code? That's one thing. The code itself, where is the code? That may sound a strange question, but sometimes people don't know which code is in production. There was a version that went to production, then someone patches something in test environment, and then they made it. And sometimes we lost the track of the code. Sometimes it happens, not if you good practices, not, but sometimes it happens. And now, what is the quality of the code that is in production? Do I know if there are vulnerabilities? When was the last analysis that I did on my code? And it doesn't matter. Even if it's only for forensics, if there's a problem and my data gets compromised due to some security issue, how can I measure the impact of that leak, of that breach? How can I measure what was the steps? What are the steps I need to take to protect it? So I need to look into the code at least for forensic analysis. Well, I don't have to look into the code, but will help me out trying to understand what could be the potential impact, okay? Because sometimes logs are not enough. Also, what components am I using? Are they all components are secure? Do you all remember Heartbleed issue? Do you guys remember Heartbleed issue? OpenSSL, that leaking information? It was based on OpenSSL. It was an open source component, which was, 95% of Linux distributions used OpenSSL, and there was one guy maintaining it. And the guy decided, oh, I need to get married, I want to buy a house, I need to make money. So decided to leave and drop the project. And suddenly Apache didn't have anyone to maintain OpenSSL. And suddenly Heartbleed appeared, and there was an issue because the Heartbleed was 0 day for a long period of time. And even after the patch was released, people didn't patch everything. So still are a few open doors in Portugal with OpenSSL. So knowing what are my open source components is important. It's an important aspect of DevSecOps. Also, you all know about Equifax, right? Structs, Apache structs, didn't patch, the bug was there was an issue, okay? Open source. We need to know which components we are using. That's critical. in the same way that you know which version of Windows you're using, which version of the firmware of your firewall you are using. So we need to know what are the versions of software. So we can act, so we can be aware of the notifications, the publications of vulnerabilities, and act on that. Contracts, okay? I talked about people, the code, the components, and what about my contractors? Are the people of my contractors able to develop secure code? Is the code that my contractors develop able to be secure and tested and doesn't have flaws? Do my contractors are using the correct sort of approved open source components that I've whitelisted? The same, okay? And then in the end, governance, okay? We'll make the decisions. What are the risks? Which risks am I willing to take? Which risks I'm not able to take? And who approves exceptions? There will be exceptions. There will be a version of the code that will be flawed, but nonetheless, we'll need to go into production like that. Who takes the decision? So the governance, those are the aspects that we need to ask. These are some questions, okay? And when you're looking into continuous integration, continuous deployment, continuous delivery, we are creating, we are deploying into containers. We need to also ask, are my containers secure? Does the versions of my containers, the software version of my containers, are they secure? Do they have vulnerabilities? And so on. So even as we move deep into implementing DevSecOps, new questions will arise. But always look at the, again, attack surface. These are part of the surface attack of application. Okay, so what can we do to be agile during the DevOps, to implement DevSecOps? Again, reusable artifacts. That's what the first step. That's the key aspect of agility is reuse, reuse, reuse. Okay, and after you reuse, you improve and reuse again your improvements. So we can start by looking at the application security verification standard from OWASP. 212 rules of checklists that we need to validate. When you're talking about DevSecOps or DevOps for that matter, we don't really like documentation and we don't really like to have checklists to check things or not. But it's a good source of information. It's a good source for people that is at the entry level looking into learning or trying to implement safe code. It's a good way to start learning. So it's worth looking at the ASVS from open source. And I'm going to, from OWASP, I'm going to refer OWASP lots of time because it is a huge effort they've been doing. It's a huge community doing and promoting and building artifacts so everyone can build safer software. Okay. Now, another thing we can do is we can improve speed up on my test plan. If I have 3 different levels of risk categorization, like OWASP does, I can decide for each type of these applications what type of what type of tests I need to do and when. Okay, I can decide that okay, I have a low-level application or risk application. I'll be happy with pen testing prior to go to production. That will be sufficient. Or I'll be happy with static analysis of the code during development. That will be sufficient. That's a decision. But that I can have these predefined tests, and if I have my predefined components, I can test the integration of those components, and I can reuse my tests. I can have unit tests for security. Mind-blowing, unit tests for security. And note that security, you may have security requirements which are technical requirements, generic technical requirements for security, or I can even have actually functional requirements. Things like, if the user goes away for 50 minutes, the session gets invalidated. I can test this. It's something that can be tested. So I can have a unit test to do this. Again, unit testing for speed up the process. Other reference is the COM, which is a framework and a methodology for testing, which is good because testing open source, which is good because it shows about the complexities about all the stakeholders of the process of the software. And again, another aspect that is relevant is keep the attack surface up to date. The attack surface is the points where my application can be exploited. So if I have a first run and define the attack surface, every time I do an incremental change, every time I do a sprint, I can just go and check if my my attack surface had changed. And if it's changed, I can ask developers to say, please, don't do that way, do it the other way, so it can be reduced again, back to a controller state. And again, we cannot expect that the developer to know everything about determining the attack surface, because parts of the attack surface will be completely out of the mind of the developer for the first time, second time. But after some time of collaboration of different persons within the process, people will be aware what will be the changes to attack surface. And you'll be aware that if I want to access a properties file, maybe I need to do it in different ways, so it'll be secure. Or maybe if I want to access a system resource, I will need to do it in a different way, so it will be secure, and so on. Okay. Again, Microsoft Attack Surface Analyzer is an open source, is a freeware tool, not open source, but it's a freeware tool that allows to give a lot of information regarding Surface Analyzer, mainly, obviously, for Windows applications. And it has actually some tools that allow you to test in a system. You can determine the existing surface, the attack surface, and after installing my application, if there are changes to my attack surface. So that's quite a good tool for Microsoft systems. But also OWASP provides a cheat sheet for how to do attack surface analysis. Okay, then I can keep a list of a white list or a black list of components that I can use. I can develop my own components and keep them up to date to maintain them secure and make sure that they are being used. And again, we all know about NIST, National Vulnerability Database, NVD, sorry. And everyone knows about CVE from MITRE, where all the bugs and all the issues are published. MITRE also maintains the common weakness enumeration, which is quite good, but there are other references that one can use. Okay. So that's how we can agile by reuse. Can be more agile by reutilization of artifacts. But we can also automate, and you can automate and redesign. You can automate security tests. You can automate security validation. You can introduce a lot of automation in our process. To start with, we can, when typing in the code, we can use EDS to understand what new vulnerabilities I'm adding to the code prior to commit. Or I can actually have a pull request being validated automatically to check if there are new issues and if I can accept or not accept that pull request. This can be automated also. I can automatically check the code that is being committed or in a given delivery and analyze for new open source components being used, or prevent the build from happening if new unauthorized components are being used. I can automatically build my components relationships and see if there are changes to my attack surfaces and if that is acceptable or not. And in the end, I can automate security tests. Again, OWASP. OWASP has a ZAP, and it has a thing which is called OWTF, which is, it's means offensive web between commas test framework. But basically, it's a penetration test framework. It's freeware; anyone can use it. ZAP has fuzz testing. You can do fuzz testing in ZAP, automated fuzz testing. So it's an application that actually goes into my front ends and tries to select to identify inputs, and given the type of inputs, try to explore those inputs. If it is a date, try to run the application with a date prior to a given date, or try to input a valid date to see what happens. Try to put different sorts of maximum values and see what happens. It will try to use the application with completely stupid data to see how the application handles it. Fuzz data is important and can be automated with ZAD, among other things. Okay, I'm finishing, so that's quite fast. So in terms of key takeaways, first, obviously, identify things early, agile, continuous integration. Do test first. Do test. Automate the maximum of you can do. Provide self-service testing. Allow developers to test the code, to test the application. Allow them to use that. Do automated analysis. Automated analysis is really the only way we can identify some of the vulnerability issues in the code. We can do penetration test afterwards, but it will not be the same because penetration testing will be a black box action, so you need to guess what can happen, while security testing based on automated analysis will identify us the issues in the code. And we can then feed, if needed, a red team with that information so the red team can try to exploit that. Break the build, as I mentioned. During the build, if it doesn't pass the criteria of security, break it, doesn't allow it to pass, or break even the commit. Don't allow it to commit the code if the commit has issues. Know what you are using, be aware of what is the state of your application, what components you are using, and know what you are using. And also important is develop with forensics in mind. If we don't log, or if we don't do audit logging properly, the guys in operations will have a very difficult time to understand what's going on. If you want to detect someone is intruding our system, there's only really one way, which is look into the logs and see if the logs show something strange. Well, there are other ways, but that is the most common way. And there's no other way, or the application is the application itself is really the only thing in the system that knows if it is being abused or not. Is the application that can be aware if something is asking to execute an operation that user is not allowed to do. So blocking just the front end is not enough. Blocking the front end, the menu options, the link options, but then also validate that in the back office. It's called defense in depth, or one of concepts of defenses that can be this one. So if you alert, at some point in time, if you alert the system by creating an audit log saying someone is trying to execute an operation that is not allowed to, that will raise a trigger. But if you don't do it, if you don't do that, if the developers don't implement that, it will be very difficult for operations to find out that it is under attack. So develop with forensics in mind. And then, obviously, this is all about culture, about people. We need to bring the organization together. We need to help the entire organization to learn how to detect, how to contain, and how to prevent the issues from happening. We need to maintain up-to-date response plan, and so on. I'm not going to read anything more. And education and training is something that is a constant, is a continuous thing. New ways of attacking the same application occurs every day. Also, I was reading an article the other day because of this about the OWASP Top 10, which is a publication that happens now with more frequency, but there was 3 years, I think it was between 2013 and 16 that it was not published, the Top 10 was not published. And the major news about the latest publication of OWASP Top 10 is that there are no news. The same issues, the same problems, the same situations are in the top 10. They can change the order, but they are the same issues. So the same problems that developers did 10 years ago are the same problems that they are doing today. Languages change, we have new languages, we have same vulnerabilities, but you need to be able to protect those. Okay? And basically, that's it.